to explain about my project, bias detection in facial recognition systems. Coming to the project problem, facial recognition systems are increasing using real-world applications such as security, surveillance, and identity verifications. However, several studies have shown that this system can exhibit bias based on demographic attributes such as gender, ethnicity, and age. The objective of this project is to identify, analyze, and quantify biases present in facial recognition models and understand how problem performs varies across different demographic groups. Coming to the dataset, I have used UTK dataset, and coming to the model I have used techniques plus I have features extract text from face images as also bias evaluation matrix coming to the accuracy cross demographic groups, error rate differences, false positive and false negative analysis. Coming to the output, I am coming to the model performances, accuracy comparison plots, error rate distribution, confused matrix also. And coming to the project, first I have installed pip, installed the Kaggle, and next I imported the devices such as OS, random, NumPy, pandas, and also imported default directory and imported matplotlib to plot the images, and also imported a cbound and imported tqdm and also imported the images and imported the torch, and also I have imported confused matrix, accuracy score, and classification report. Now, coming to the dataset class, I have used the UTK face dataset, and this is what I have done. And next, I have transformed the datasets and data holders like this. And I also kept 10 total sample availables to that. So the total sample availables are 23,708. Training examples are 18,966 values and samples are 4742. And then I have simply used the multitask CNA for age, gender, class. Then I print the model, so you can see the model how it is, small sequential one, real U, convo, 2D, and also you can find the loss optimization helper for the gender, age, and race. And I have done the progress with the bar and life updates for epoch 3. You can see the epoch 1, the average loss is 412.6347. The epoch 4, second one, the average loss is 348.4990, and the epoch for third one, the average loss is 305.1594. And then I evaluate the collection, the predict on variable set, and then the gender accuracy and race accuracy I have done in the graph. So you can see the gender graph, validation accuracy for gender, this is, and value accuracy for race is this. Then I have predicted the age prediction error distribution. You can see the graph here where the absolute age error is, and then I have done true age bus predicting age graph. Here this is the graph, and then I implemented the confused matrix and classification report. You can see the gender confused matrix here and also race confused matrix here, which we show the white, black, Asian, Indian, and other, and the gender are male and female. And then I have written the gender classification report that as male, female, we can see here, and accuracy and macro average and weight average, you can find the numbers of here for the precision, recall, F1, force, and support. And also for the race classification report, I have used white, black, Asian, Indian, and other precision for recall, F1, score, and support, and the accuracy, macro average, and weighted average. Now I have created the bias heat map accuracy for race prediction for each gender. Here you can see the race classification accuracy by gender, male and female, for white, black, Asian, race, and Indians. And the function to display mixed classification attribute, I have done this one. And you can see the mixed classified examples gender like this one, and mixed classified examples for races, and also mixed classified examples for ages. And then I have created the fairness matrix functions, then the compute fairness matrix and displays the summary table here. You can see the summary table here for metric value for the overall gender accuracy and overall race accuracy, and is MAE, that is 12.837354. And we can see the gender accuracies and race group accuracy here over here. Then we can get to the gender DP for group favorable problems, and with gender EVO, TPR per group, and race EVO for TPR per group, and then gender DI and the race DI. Then I imported the matplotlib for the confused matrix like accuracy by gender, gender confused matrix, accuracy by race confused matrix, and I also age group bin confused matrix here, and I also save the outputs in the output directory where you can see that. In the conclusion, I want to explain you regarding that. In this project, bias detection facial recognition model was systematically analyzed by evaluating model performance across different demographic groups. The experimental results revolved on noticeable disparities in the recognition accuracy among these groups, confirming the presence of algorithm biases within the model. And also, these findings highlight the ethical challenges associated with deploying facial recognition systems in real-world examples. Biased models can lead to unfair outcomes, reduced reliability, and loss of the trust in the artificial intelligence technology. Therefore, identifying the addressing bias is a crucial step forward responsible AI development. And coming to this project demonstrates the importance of the balanced data sets like fair model training practices and continuous evaluating to mitigate the bias in the facial recognition system. For the future work may involve applying bias mitigation techniques and improving the dataset diversity and exploring the fairness aware learning the algorithms. Overall, the studies reinforce the need for the ethical considerations and fairness in the modern AI systems. Thank you. This is my project.